Rakshit, put the code. Rakshit Prabhu, code akba.
Good morning, dear students.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Fine. We'll get back to the worksheet 2. We were at, I think, 12th question. Am I right? Do we need to work out 12th or 12th is complete?
We should do 12th.
Yeah, we should do 12th. Okay. All of you are ready? Shall I proceed now? Shashank?
Ready, sir.
Yes. Okay. That's the energy. So fine. So we'll take up 12th question. Come on. I'll just go through. Which of the graphs shown below does not represent the relationship between incident light and the electron ejected from the metal surface? Which is wrong?
Sir, third one.
First one, third one. Remaining two options are there. If anybody cover that also, all the options will be fine. Huh? Okay, there is some option A, Brinda. Okay. Next.
Yes, sir. It's option A.
Vikram, tell me, man.
So option A.
Option A, sir.
Is wrong, huh?
Sir,
No, sir, it's right.
So the answer is option A.
Meaning it does not represent. That's what you mean by saying.
Yes, sir.
Okay. Because they're asking which of the graphs shown below does not represent the relationship between the incident light and the electron, that is photoelectron. Okay. Let me take the one there. Number of electrons along y-axis, frequency of light along x-axis. And whereas in option 2, kinetic energy of electrons along y-axis, intensity of light along y-axis, x-axis. So in third one, kinetic energy, y-axis, frequency, x-axis, kinetic energy. In the fourth one, y-axis, energy is nothing but again frequency. You can say both same. Okay. Now, which is most correct here? Can you tell me which is most correct?
Fourth one.
Why? Because it is the photoelectric effect. That's how exactly photoelectric effect happens. So if some radiation is incident, not for all the incident radiation, electron will be ejected. A particular frequency is required or energy is required. That's called threshold energy, for which electron will be removed. And this point you can see on the screen, I'm marking that. That point represents the threshold energy or threshold frequency. Beyond that, if incident radiation increases the energy, then kinetic energy increases. So this graph, fourth one, is correct. If fourth one is correct, immediately what is the conclusion? Third one should be wrong. Because both are same along x and y axis. Kinetic energy along y axis, frequency nothing but energy. Same, no? So when kinetic energy versus frequency or energy is plotted, the same graph, if fourth is correct, obviously third should be wrong. Yes or no? Vikram?
Sir, but we can still increase the kinetic energy of electrons with higher frequency, no, sir?
But this graph shows that almost from the initial frequencies itself, the electron increases the kinetic energy. That is wrong. First of all, with the initial frequencies from 0 onwards, electron will not be ejected at all. Every metal require minimum sufficient energy to remove electron, that is threshold energy. So graph 4 correctly depicts the photoelectric effect. If graph 4 is correct, obviously graph 3 should be wrong.
Yes, sir.
I'll come to point, option 1. I'll come to option 1. Now, is this understood? Graph 3 is incorrect.
Sir, graph 3 means threshold energy should be 0.
Which is not possible.
Yes, sir.
So 3 is incorrect. Now fine. Then how about 1? 1 also seems to be something weird. It is different. So if you look at this, number of electrons ejected along y-axis and frequency. Now, is there any relation between number of electrons and frequency? No.
No, sir.
Because number of electrons ejected only depends on intensity. So that's why when frequency is increasing, number of electrons ejected remains constant. That's why the graph is parallel to x-axis. Then why is that hike in the beginning? That is only for those
One electron is
electrons
ejected.
which are matching with the threshold frequency.
Yes, sir.
So graph 1 is correct because number of electrons ejected doesn't depend on the frequency. If frequency increases, number doesn't increase, only kinetic energy increases. So graph 1 is correct. Graph 2, kinetic energy of electrons versus intensity. If intensity increases, does kinetic energy increase? No.
No, sir.
So therefore, kinetic energy remains constant. Kinetic energy of emitted electron would only increase with frequency, not intensity. So graph 2 is also correct. The incorrect one is 3. Okay. So fine. And also mathematically, if you want to go for the solution, you know this h nu is equal to h nu naught plus kinetic energy as per photoelectric effect. Am I right? So kinetic energy, if you take h nu minus h nu naught, and you can take this nu naught into the bracket and it becomes plus, because this form, okay, is similar to y is equal to mx plus c. Y is equal to mx plus c indicates what? A straight line. But where in this straight line y is equal to mx plus c indicates the intercept. Negative intercept means it has to come like this. Correct? No, it cannot go like this. Now option 3 would be possible when y-intercept c is 0. So therefore mathematically also third option is wrong, because when we plot kinetic energy against frequency, there should be negative intercept possible. Here there is no negative intercept, there is no intercept at all. It is passing through the origin. Okay, so mathematically also you can thus conclude 3 is incorrect. Shall I proceed? Would you like to write down? No intercept here.
Sir, in other words, can we say this relation of electron ejection, it should not pass through zero, no, sir, that is origin. Then if it passes, it's wrong.
Correct. It means the same.
Yes, sir.
Okay. Shall I proceed to 13 now? All of you done with it?
Yes, sir.
People have to respond. Don't wait for others to respond. You respond first.
Yes, sir.
13. The radiation of low frequency will be emitted in which transition of hydrogen atom?
So second option n equals 2 to n equals 5.
Okay. Low frequency. Low frequency will be possible between 2 and 5.
So fourth.
Low frequency
Fourth.
corresponds to low energy. Vrinda says option 3.
Sir, option yes.
Option 2.
Now let me write the atom here. This is the nucleus.
Sir, first stop.
3.
Fourth energy level. Fifth energy level. 1, 2, 3. This is 4. Let me draw one more. This is 5. Now they're asking low frequency corresponds to low energy.
Sir, second option.
It will be
How can it be the first
transition of hydrogen.
two options, sir?
Sir, first two options, there will be no emissions of it. There will be absorption of energy.
Very
Yes,
good.
sir.
So,
So
it
fourth
should-
option.
3 to 1, it will be energy will be high, so it should be option 4.
Yes, sir.
Yes,
Option
sir.
4.
Yes, sir.
Correct. Your analysis can eliminate two answer. Emitted wouldn't be possible with the option 1 and 2 because whenever electron from lower energy level to higher energy level it is promoted, it is absorbed.
Option.
So fine. Now 3 and 4, which is correct?
4.
4 is correct because 5 to 4,
Only one energy level.
only one energy level difference. The difference in energy is only 5 minus 4 because energy difference will be emitted as radiation, correct? So always we can say the frequency is nothing but energy of the emitted radiation. That will be dependent on the difference in energy of energy level where electron transition takes place. So 5 and 4, the difference is only one energy level. 3 to 1, the difference is 2 energy level. So obviously more energy and this is less energy. So option 4 is correct.
Sir, does the position matter? Like the third option is more nearer to nucleus, no, sir?
No. Which position when I say you mean by electron position?
Yes, sir.
No. See, electron is transiting from between which energy level to which energy level. You have to find out because the difference in energy is emitted as radiation of a particular frequency. If difference in energy between energy level is low, then frequency emitted is also low. Now, what is the difference between 2 and 5? There are 3 energy levels. First of all, it is not emitted, it is absorbed. Are you understanding? 2 to 5. But they are asking emitted energy. Emitted comes to only when electron transition takes place from higher energy level to lower energy level. So third and fourth, between that, the energy level difference is minimum in option 4. So frequency emitted is also low.
Okay, sir.
Okay. Shall I proceed now?
Yes, sir.
14. The first emission line in Balmer series of hydrogen spectrum will have the wave number. What is the first emission line of Balmer series? What would be N1, N2 values?
The N2 would be 3 and N1 would be
2, 3, sir.
2 will be N1, 3 will be
Sir,
N2. Correct.
So then
sir,
option
Balmer
1.
series is 2, 4, right?
No. N1 is 2 for Balmer series. And N2 can be anything more than 2. N2 can be 3, 4, 5 like that. Correct. N1 is 2. When N2 is equal to 3, it is H alpha line. When N2 is equal to 3, 4, it is H beta. 5,
Beta.
H gamma. 6, H delta like that I told you.
Sir, option 1.
Sir,
5.
then is it
Shashank, you muted.
then it is 2, 3, sir.
Then tell me, what is the correct answer? Keep the
Sir, first one.
first option.
Sir, I didn't get this one.
Okay. I'll just give the answer. You can see this atom itself, which I have written there. It avoids me to write once again. Now, for Balmer series, what is N1?
Sir, 2.
N1 is equal to 2. Now, any transition of electron which ends with N is equal to 2 would give Balmer line.
Yes, sir.
First line means what? First line would be possible when electron jumps from third energy level to
Second energy level.
So what is N2 therefore?
Sir, 3.
That's all. Actually, when electron goes from 3 to 2, what is it called? Basically, it is called H alpha line. They're asking about H alpha line. First line means H alpha. Second line is H beta. Third is H gamma. Fourth is H delta.
Sir, that's all. How do we... I didn't understand what 5R by 36, 3R by 4 is, sir.
Oh, okay. You mean... Okay, I just need to solve it. That's all. Listen to me now. The formula is nu bar is equal to RH into 1 by N1 square 1 over N2 square.
Okay, sir.
RH means R they have given, no problem.
Yes, sir.
N1 square is 2 square, 4. 1 by N2 square is 3. 3 square, 9. What is the LCM?
Sir, 36.
So R into, this will be, 36 is the LCM.
Yes, sir.
9 minus 4 by 36 is 5 by 36 times the R. So option 1.
Sir, no need of writing the Rydberg constant values.
No need, because they have given answers in terms of R only, no?
Sir, if they have not given this in the form of multiple choice, but we should solve it, then we should take it take the value.
Correct. Exactly. The R value is 1.09678 into 10 raised to 7 per meter. Then you have to take that one and do it. That's all.
Yes, sir.
Fine. So option 1 is correct. Complete?
Yes, sir.
Yes. I'll proceed to 15 now. What are the N1, what are the values of N1 and N2 respectively for H beta line in Balmer series of hydrogen spectrum?
Sir, option C.
3.
Correct, no? I'll go back to this diagram of atom. You can see here electron transition from 3 to 4, 3 to 2 is H alpha. Next line, second line, what we call will be 4 to 2 will be H beta. Okay, so N1 should be 2, N2 should be 4. So option 3. Okay. Next, 16. The number of spectral lines.
Can you go to the previous?
Pardon me?
Sir, can you go to the previous page for a moment?
Yeah.
Yes, sir.
16. The number of spectral lines that can be possible when electrons in sixth shell in hydrogen atom return to the second shell. Okay. Here they are asking, when electron transits between any two energy level, how many spectral lines are probable? Okay, so now there is formula. Let us discuss little more on this question. Just know about this concept. So we know that whenever electron transition takes place between higher energy level to first energy level or any energy level, the transition can happen at a stretch, or the transition can happen in steps. Let's say electron is jumping from 8th energy level to lower energy level. What are the possible values? What are the possible transition? 8th to first at a stretch. 8th to first at a stretch, or 8 to 7, 7 to 6, 6 to, like that. Different possible transition could be possible. Or 8 to 2, 2 to 1, 8 to 3, 3 to 2, 2 to 1. So different possible transitions would be there for an electron which could jump from higher energy level to lower energy level. There is a formula to calculate number of spectral lines formed when electron jumps from higher energy level to lower energy level. The formula is like this. You just need to write down number of spectral lines formed. It is N, capital N, is equal to N2 minus N1 into N2 minus N1 plus 1 divided by 2. Okay. N2, N1 same notations.
So
N1
fourth
lower
one.
energy level.
Sir, fourth option.
Exactly. So N1 is lower energy level, N2 is higher energy level, same thing. Okay. This is for transition of electron between any two energy levels. Okay. If you keep for Lyman series, the equation reduces to simplified form for Lyman series. What is N1 value? 1. So therefore, N is equal to N2 minus 1, N2 minus 1 plus 1 divided by 2. So this to get cancelled. What remains is N2 into N2 minus 1 divided by 2. I can write without the subscript 2 there, simply as N into N minus 1 by 2. Same equation for Lyman series, it reduces like this. That's all. Where N is the higher energy level. There is no lower energy level because we have substituted lower energy level value as 1, and then we have got this expression N into N minus 1 by 2, especially for Lyman series. That means when electron jumps from higher energy level to first energy level, you can use this formula. Otherwise, use this formula. After writing down this, let us come back to this question. Answer has been given already correctly. Option 4. The number of spectral lines that can be possible when electron in 6th shell, so N2 is 6, in hydrogen atom return to second shell. N1 is 2. They have written as delta N here. You can write this is plus actually. Same thing. N2 minus N1 can be written as delta N. That's all. Delta N into delta N plus 1 by 2 like, or both are same. N2 minus N1 is delta N. Shall I proceed now? Six minus 2, 4 into 5, 20 by 2 is 10 lines. So option 4 is excuse me. Is it finished? If you once complete, you have to let me know.
Done, sir.
Oh, so I'll go to next. I'll remove this part. Next question. Which element has a hydrogen-like spectrum whose lines have wavelength 1/4 of that of atomic hydrogen? Now you need to identify the element which has hydrogen-like spectrum whose spectral lines have the wavelength which is equal to 1/4 of the wavelength of the hydrogen spectrum. You need to incorporate the condition.
Sir, is it lithium?
Helium.
Lithium?
Sir, boron.
Helium.
4 plus.
So
Boron, sir.
appreciated for spontaneity. Who said lithium?
Sir Shashank.
Beryllium? Boron?
Sir, I said boron.
Helium?
Sir, I said Varsha.
Okay, Varsha. How is that helium, madam?
Sir, actually, they have told 1/4 of atomic mass of hydrogen, no, sir.
Correct.
So
Not atomic mass.
atomic number will be nearly 2, so helium.
Okay. Let's see.
Sir,
who is
energy
there.
is can
Tell me.
Z square by n square, and this is 2, so Z will be 2. You can square it, you get 4, somewhat closer to the answer.
So it is beryllium. Huh?
No, sir, helium could
Helium.
be.
Okay. Abhinav,
Yes, sir.
let's see. Okay. Huh. Okay. Let's see what is the equivalent. So they have given this like this. See, the which element has hydrogen-like spectrum whose lines have wavelength 1/4 of the atomic hydrogen. So wavelength lambda of the element, I'll say EL for element instead of writing completely, is 1/4 the wavelength of hydrogen. Correct? Take the reciprocal. Therefore, 1 by lambda of the element is equal to 4 divided by lambda of hydrogen. But what is 1 by lambda? R into 1 over 1 by n1 square minus 1 over n2
Sir,
square.
1 by lambda is mu bar.
No, that's fine. New bar expression is what I'm going to write. Okay. So, but 1 by lambda is nu bar is nothing but R into 1 by n1 square minus 1 by n2 square is the expression. Of course, there is z square also. For hydrogen, z is 1. So we don't write generally for hydrogen, z square. Let me write this. 1 by lambda of element would become what? Z square into R into 1 by n1 square minus 1 over n2 square. Correct. Is equal to 4 into what is 1 by lambda hydrogen? Z is 1 there. R into 1 over n1 square minus 1 over n2 square. So this 2 get cancelled. Now, therefore, somebody told me correctly, z square is 4. Therefore, z is equal to 2. Varsha and Avinav. Z is 2 is helium. Correct?
So did you make an assumption for 4, sir?
Assumption for?
Sir, how did you get 4?
They have given 1/4.
Oh, okay.
I didn't assume. I'm not bored. So, Vrinda, I think you got the answer. Okay. Write down this. Let me know when it's complete. It's he. Who is he? He is helium. Okay. So, hope all of you have written down. Shall I?
1 minute.
Sir, just a minute, sir.
Okay. Right. Shashank done?
Excuse me, sir.
Yeah, tell me.
So how did we get is equal to 4 into R? How did we substitute 4 over there?
4, they have given in the problem.
Yes, sir. That I understood. For 1 by 4th H I understood, sir.
Then
But
I have taken reciprocal.
for Z square, how do we substitute the 4?
No. I didn't substitute. That 4 was there as it is. This is the equation we know. Okay. So therefore, 1 by lambda of element is what? Nothing but this equation.
Yes, sir.
What is the equation? Z square into R into this. So 1 by lambda of element, I've written it as z square into r into 1 by n1 square minus 1 over n2 square.
Yes, sir.
And that is equal to 4 into 1 by lambda of h. For h, what is z? 1.
Yes, sir.
So 4 into r into 1 over n1 square minus 1 over n2 square.
Yes,
R
sir.
and this quantity will cancel. So z square becomes equal to 4.
Sir, then we should assume that 1 by n1 square minus 1 by n2 square is same for both the elements.
Yeah, of course, because which element has hydrogen-like spectrum whose lines have wavelength 1/4 that of this one means the rest would be same because they have not given anything else.
Yes, sir.
So shall I proceed now? Vikram, understood, man?
Yes, sir. Yes, sir.
Oh. Eighteenth will take it. Energy of electron in first orbit of hydrogen atom is minus x. The energy of electron in third orbit of He plus is
Third option.
good.
Yes, sir. Third option.
Okay. What is the? How is that, Abhinav?
Sir, we know the equation. E energy is the constant divided by n square into z square. If we take like if we relate with
Square by n square or n square by z square?
z square by n square.
Yeah, exactly. Right. That's the
If
answer.
we relate it with minus x, we'll get E4 and we can
Correct.
simplify
Okay.
it.
So let me give the solution for this. See, we know this equation. As per Bohr's theory, energy of electron in nth orbit of hydrogen atom is this. Correct? No? We know this. En is equal to minus 13.6 electron volt z square divided by n square. Okay, they have given energy of electron in first orbit of hydrogen is minus x. First orbit, so n is equal to 1. So 1 square. For hydrogen, z is 1. Now, how much ever it remains is minus 13.6, no? That is given as x. Okay, they have given it as x. Energy of electron in first orbit of hydrogen is minus x. Now, the energy of electron in third orbit of helium, use the same formula. Excuse me. For third orbit of helium, n is equal to 3. For helium, z is 2. So En is equal to minus 13.6 divided by n square is 3 square into z square is 2 square. But what is minus 13.6 is? Minus x. Am I right? So that means whole value is x there. So it doesn't become minus into minus plus. The value is x there. So 2 square is 4, 3 square is 9. So 4 by 9 into x. So option 3 is correct. So hope all of you have understood. Shall I proceed now? Still writing?
Finished, sir.
Meaning I can proceed.
Yes, sir.
Okay. 19th will take it. The splitting of spectral lines in presence of magnetic field is?
Sir, Zeeman effect.
Zeeman effect.
Then
Zeeman
what is
effect.
splitting
Zeeman
of
effect.
spectral line in external electric field?
Sir, Stark effect.
Stark effect.
Okay, so it is option 2. Exactly. If you want to know why that line split in external magnetic field, that is actually out of this question. Just for your curiosity, whenever spectral lines are passed through external magnetic field, the lines will split. That's because, see, there is orbitals in hydrogen atom. 1s orbital, 2s orbital, 2p orbital, like that. We know 2p subshell has 3 orbitals in it. Okay, so electron transition, every time when it goes to any one of the 3 orbitals and comes back, then there will be possibility that there can be different energies there. Okay, so electron transition from lower energy level, that is ground state, 1s orbital of hydrogen, to different suborbitals or orbitals of the 2p subset, when it takes place, px, py, pz, would give rise to different energies and thus different spectral lines. So that's the reason why a spectral line in presence of external magnetic field appears as split into lines. Okay, the transition would happen between different orbitals of p subshell with 1s. So since different transitions are possible, so different lines are obtained. Just know about it. That's all. Okay, so you will take up in second year PUC, there is something called crystal field theory, which also deals with this kind of transitions. There you will get more clarity about it. Okay, fine. So option 2 is correct, Zeeman effect. 20. And the basis of Bohr's model, the radius of third orbit is?
Third option.
Third option, sir.
9 times to that of first orbiter. So the reason is n square by z. That's it.
So the formula is n square by z square, no, sir?
No. Radius is n square by z.
Okay, sir.
Energy is n square by z square by n square. And velocity is
Z by N.
z by n. Okay, right. So radius of electron is n square by z. So they're asking for the, on the basis of Bohr's model, radius of third orbit would always be n is equal to 3. 3 square would be 9. So whatever, 9 times to that of first orbit. So option 3 is. Okay, shall I proceed now?
Yes, sir.
21. If electron, hydrogen, helium, and neon nuclei are all moving with velocity of light, then the wavelengths associated with these particles are in the order. Are they speaking
Question
about
one.
normal wavelength or matter wavelength?
Sir, can you repeat it?
Are they speaking about simply wavelength or wavelength of the matter wave?
Matter waves, sir.
Exactly.
Matter wave.
What is the answer?
So it is
Option
1 by
one.
mass. So inversely proportionate to mass, no, sir?
So
So then electron will have the most wavelength in that
Sir,
case.
electron.
So first option.
First answer, electron, hydrogen, helium, and neon.
exactly.
Yes, sir.
That's the correct answer. See, wavelength lambda is inversely proportional to mass of the particle. As mass of the particle increases, wavelength decreases. So if you see the particles they have given here, electron has least mass, hydrogen next, helium next, and then neon. Right now, mass increases. When mass is less, wavelength is more. So option 1 is correct. Okay. Shall I proceed now?
Yes, sir.
22nd, a golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured within accuracy of 2%, calculate the uncertainty in the position. Delta x they are asking. And what is the 2%? That is the uncertainty in velocity, speed. Dhanushri asked me for previous page. You others, please go through this one. I'll just go back and come back. Okay, I'll go to next page then. Yeah, anybody has got the answer for this? Use the Heisenberg uncertainty principle. Delta P is nothing but momentum uncertainty.
Sir, option 1, sir.
Mm-hmm. 10 raised to minus 33 meter. Okay, how about remaining?
Sir, it is 1 by 36 into 10 to the power minus. Oh, it's given in decimal.
So finally, what is the option?
Option 1.
Okay. Including us, there is 52 in the class. But I am hearing the voices of around 4, 5, 6.
Sir, option A, sir.
Option A, man. Okay. So Ravi Teja, there's somebody, Ravi Teja here. Did you work out, man? Ravi Teja? Ravi Teja, can you hear me? Rujula? How about Rujula? Rujula, what is your answer? See, many of you doesn't respond. That's the problem. To keep yourself motivated and have interest in the lessons, first try to interact. Need not be always unmuting mic and speaking. You can chat here. See, some people are, responding. Option A, and please go back, or yes, repeat, or something like that. You have to keep responding and interact with the teacher. Then you will have kind of attention and you will be committed for the class. You will understand better. So,
sir.
I think this guy has in between. Tell me, Chachang.
It's okay, sir. You finish it. I'll tell it afterwards.
Okay. So, like that, see how he interacts. The moment he gets some idea.
So it's option A, sir. 1.46 in 10 power minus 33.
Is it, man? Okay. That's fine. I want all of you to interact, remaining people also, please. Okay. We'll take up the solution for this. Let's see who is correct. I'm getting option 1 as by most of the people. The equation, Heisenberg uncertainty principle, delta x into delta p is equal to h by 4 pi. And we need to have this delta v out of delta p. because delta P is uncertainty in momentum. Momentum is mass into velocity. Uncertainty in velocity we have to write here because it is delta P. Okay, right. So therefore delta X is equal to h divided by 4 pi into m into delta P. Let's substitute the values. H is 6.625 10 raised to minus 34. 4 pi is 3.14 into mass is 40 gram. Shouldn't we convert it into kg SI unit? 40 gram is nothing but 40 into 10 raised to minus 3. And uncertainty in velocity. See, 45 is the meter per second speed, but there is 2% uncertainty. So you have to multiply that. So 2%, 2 divided by 100 into 45. Is that okay? So when you simplify that, it would come to 1.46 into 10 raised to minus 33. So option 1 is correct. So as most of you people given correct answer. Okay. So you can 6.625 divided by this 100. If it moves to the numerator, it becomes 10 raised to 2 becomes 10 raised to 32. And if this minus 3 goes to numerator, plus 3, again it becomes 29 minus 29, right? So 6.6254 into 3.14 into what is this 40 into 2, 45 into 2, 90. 90 into 45 is 3600. That 3600 10 raised to 2 can go to numerator, minus 2, again 10 raised to minus 31, it will be minus numerator, and numerator denominator will be 36. Okay, if it is approximately slightly greater than 2, slightly less than 2, and it will be 71, 1 by 71 into 10 raised to minus 1 by 71 0.014, correct? No. So if you shift the decimal, it becomes 1.46 into 10 raised to minus 33. 1 by 71.001 into 10 raised to minus 30. 0.0, sorry, 0.014. So shift the decimal, it becomes LIRD, right hand decrease the power. So it becomes 1.4 into 10 raised to minus 31. Write down. This will be just 0.01. All powers must be attested simplified. This is 10 raised to 2 goes to numerator because it is 1 divided by, no, it remains as 10 raised to 2 itself. There is 10 raised to minus 3 here, goes to numerator. I have multiplied 2 into 45, 90, 90 into 40, 3600, 36 into 10 raised to 2, that also you push it to numerator so that the ratio will be simplified. Approximately you have to calculate so that nearest answer you will get the answer with slightly faster. In CET, approximations would be sufficient. Exact answers are required in board. Fortunately, you can use the calculator in board, but not in CET. Let me know if it's done. Shall I proceed now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Thank you. Done. Okay. So I'll just rub that portion. Next question.
So
What will be
second
the
option.
tell me?
Second option.
Second option.
Okay, I'll just read it. As per board norms rules, we have to read the question first. What will be the wavelength of a ball of mass 0.1 kg moving with a velocity 1000 centimeter per second? But answers are there, mixture in meter, centimeter, and everything. Okay. What will be the wavelength of the ball? So it means the concept of de Broglie matter.
Sir, option 2.
Option 2. Okay. Because denominator becomes 1.
1.
Exactly.
Yes, sir.
See, the equation is lambda is equal to h
H
divided
by
by
L.
m into v. What is h? 6.62 10 raised to minus 34. Mass 0.1 kg. Correct? And 1000 cm cube, 1000 centimeter per second they have given. So 1 centimeter, 1000 centimeter is equal to 10 meter. So you can always take this 10 raised to 2 and centi get cancelled. Centi means 10 raised to minus 2, correct? Centi is 10 raised to minus 2. These two zeros 10 raised to 2 get cancelled. What remains is 10 centimeter. So 10 meter. So 1000 centimeter is nothing but 10 meter. So denominator 0.1 into 10 is 1. So it becomes 6.62 into 10 raised to minus 30. Option 2. So I proceed.
Yes, sir.
Next.
Yes.
The basis of quantum mechanical model of an atom is, see, we are going to take up the next concept is there is little bit about quantum mechanical model of an atom. Okay, Bohr's theory is failed, and of course long back Rutherford theory failed, and later which is not there in the syllabus, that is called Summerfield model, that is also fails. But finally one concept has been prevailing now till now. It is quantum mechanical model of an atom, and we are going to discuss brief about it after this. Okay, that part will not be there for the examination. Don't worry. That means for the test you will have till whatever I have covered. That little bit about quantum mechanical model will do that. But anyhow, quantum mechanical model of an atom is a result of de Broglie's matter wave and Heisenberg uncertainty principle.
Sir, so is it option 3?
Dual nature
Yes,
of
sir.
electron. Okay.
Particle nature and wave nature.
Exactly. So since till Bohr's theory, the concept prevailing was electron is a particle. But after de Broglie matter wave, we concluded electron just not a particle; it is also a wave. So the branch of science which deals with properties of the matter, considering the wave nature as well as particle nature, is called quantum mechanics. So later quantum mechanical model for an atom will be given. So that we'll discuss later. So, but the model is because of dual nature of electron, the concept of matter wave. Okay. So option 3 is correct. Okay. 25. 20. We can talk only in terms of probability of finding an electron around the nucleus, because we can only say in this area electron is most probably present, but we can't confirm it. If this position it is there now, we can't say that.
The second option.
So second option.
Second one.
That is according to
Heisenberg.
principle. Both the exact position and the exact velocity can't be determined simultaneously. So that's the reason. If position and velocity can't be determined simultaneously accurately, we can't say position and velocity particularly or precisely for an electron. So option 2 is.
Sir, option 3 could also be the
So because it holds
It
good.
is just a wave. but not a uncertain thing. Okay, so it's
Yes,
about
yes,
probability comes out of uncertainty.
yes.
26. Which statement is wrong about Bohr's theory?
First,
The first one.
First one, sir.
First one reads like this: orbit is a three-dimensional area where probability of finding electron is maximum. That statement is correct, no?
it's correct, but board didn't give that, sir.
Yes, sir.
And that too, it is not orbital they have given.
Yes, sir.
They have given orbit. Orbit is not a three-dimensional area. Okay. And Bohr simply said that electron revolves around the nucleus in circular paths, energy levels, orbits, something like that. It's two-dimensional.
Sir, he did not mention anything three-dimensional, sir. So that's
Exactly.
why.
So orbit is a three-dimensional area? Never. Orbit
No,
was
sir.
two-dimensional one according to Bohr theory. So wrong about Bohr theory is he didn't mention about orbital. He just said two-dimensional one. So option one itself is wrong. And even the statement orbit is a three-dimensional area, that itself doesn't match because orbit is not three-dimensional. So option one. Okay. I shall proceed now. 27. Identify the correct statement regarding photoelectric effect.
The option 2, sir.
Exactly.
Yes, sir. Option 2.
So number of photoelectrons emitted is directly proportional to the intensity of the radiation, whereas kinetic energy is directly proportional to the frequency of the radiation. Correct. Option 2. 28.
So isn't it the square of the intensity of incident light, or is that square of amplitude, sir? For number of photoelectrons.
Amplitude, when you take, it could be square, but not intensity. Intensity is a result of amplitude.
Okay, sir.
28. Which of the following order is correct with respect to wavelengths of X-rays, radio waves, visible light, and IR radiation?
Sir, option 4.
Yes,
Sir,
sir.
option
4 then. A less than, C greater than, B less than D. That's the answer.
Sorry, sir.
Shashank, you will respond and immediately mute your mic so
Sir,
fast that you will be
second.
still speaking. I will not be able to hear.
Second one.
Shashank.
Second option, sir.
The second option.
Okay. Shashank, is it correct?
Just a minute, sir.
No, no, I'm telling you, you will mute mic so fast that you will be still speaking, that will be muted already.
Sir, that one, I'm holding the space bar now, sir. As soon as I leave it, go on mute. That's it.
Okay. That's fine.
Sir, because wavelength is inversely proportional to the frequency. No, sir.
Correct.
So radio waves has the maximum wavelength, sir. So B last in B, only second option has B in the last. So
What is
others
that
cannot be.
word to remember for electromagnetic spectrum?
R mu gamma C.
R mu gamma C. Just remember that. That's all. In this R mu gamma C, from R to C, wavelength decreases. Correct, no? So they're asking about which of the following order is correct with respect to wavelengths only. Now look at the X-ray, radio waves, visible rays, IR. Let us mark it. Radio waves they have given, X-rays they have given, visible rays they have given, IR rays they have given.
There is no need of marking only, no, sir, because radio waves has the maximum, no, sir. So in all the option it's D, but only in second option it's B. So it should be B.
Yeah, can be.
Yes, sir.
I'm just explaining the concept. That's all. Okay. So R mu gamma C, when I say, so here only radio waves comes the highest. B is the highest. So highest wavelength should be on the right hand side. So B is there only in 2. That's all. Correct, no? So it is option 2. ACBD, ACDB. Okay. Shall I proceed? Yes, Pranati. Done.
Yes. Yes, sir.
Oh. 29. Which one of the following is an isobar of 6C14?
3. Option third one.
What is isobar? Same.
Mass number, different atomic number.
So option 3 is 30. Which of the following statements concerning sunlight is false?
Second one.
Sir, I think it cannot be deflected by a magnet. I think that is correct.
Yes, sir, it cannot be deflected by a magnet.
It's false, huh?
Yes, sir. Option 2 is false.
Yes, sir, it's false.
Then remaining are right. It consists of photons of same energy, right? Huh?
So when we pass, sunlight will get spectrum. Now it is not a part of the spectrum. We will get spectrum from it.
Yeah, it is a part of electromagnetic spectrum. Sunlight has electromagnetic spectrum in it. That's what you mean by saying. Right now?
The photons of same energy.
Sir, option
Sir, option
3, I think, sir.
Sir, if it has photons of same energy, then only one type of radiation we can get, no, sir.
So option 3 is false or true?
Sir,
Sir,
option C is
answer is
also
option
false.
3.
2 also is false.
Okay. Everything is false, man. Huh?
Sir, one doubt. So if sunlight contains same type of photons, then only one type of radiation can give out, no, sir. But sun gives out many kinds of radiation.
So option 3 is true or false?
False.
So in that case,
False.
option 3 is false.
False. Then what about, then remaining thing should be true.
Sir, but how can it be deflected by a magnet? So it's a
Yes,
type of
Sir, that
radiation.
is also false.
That Shashank has to tell. Shashank,
Sir?
you said option 2 is false, no?
Yes, sir.
It cannot be deflected by magnet.
Yes, sir.
That means it can be deflected by magnet.
It cannot be deflected, sir.
No, if that
Sir,
is
it
false,
has-
then what is true?
Sir, it has both electric field and magnetic field.
So it can be deflected.
Part of a spectrum.
Okay.
But it has no mass.
Now,
But
okay, with all this discussion with you, please
Sir,
give the final answer.
Sir, option 3.
Sir, 3.
Sir, option C.
3 is false.
3.
Yes, sir.
3, sir.
Then remaining thing should be correct.
The first and fourth is correct.
Okay.
Sir, sunlight cannot be deflected by a magnet is true. How can it be false?
Yes, sir.
Sir, that is true, but we can see that it is a part of electromagnetic spectrum. So because of its spectrum, we have electric field and magnetic field.
So because of its wave nature, it should be deflected by magnet.
But we know that photons don't have mass, so it should be considered.
So according to Abhinav, what is false?
Sir, option 3 is correct, sir. But we can see that it makes like sense intuitively, like because we have something like photon, it doesn't like get deflected by magnet. But I'm asking how. Because we know it has two.
Okay, so this question is slightly confusing. I understand. Now, coming to option by option, it is a form of energy. Accepted?
Yes, sir.
Yes, sir.
It is not false. So they're asking about false. It is true. It is not false. It cannot be deflected by a magnet is true actually. For the reason that we may say sunlight has electromagnetic radiation, and electromagnetic radiation has electric field component and magnetic field component, meaning it has both natures, electric and magnetic nature, which means naturally by common sense we can say if it has a magnetic and electric field component, it must be deflected. But that is the thing about electromagnetic radiations by sun. So that is, when they are passed through magnetic field, they will not be deflected. They go straight, for the reason that they doesn't have mass. They have the nature of magnetic field component and electric field component. There is no charge exactly. There can't be plus and minus charge there. And the light has no mass. Because of these two reasons, electromagnetic spectrum, electromagnetic radiation, despite having magnetic and electric field, since they doesn't have mass and charge exactly there, they doesn't deflect in the presence of external magnetic field. So it cannot be deflected by magnet is correct. It is not false. It consists of photons of same energy is wrong, because it consists of, as Vikram pointed out, it consists of photons of various energy. R evokes gamma c. Frequency varies, energy varies. So photons of different energies are possible in sunlight. It would give rise to entire range of electromagnetic spectrum. So 3 is false. And it is a part of electromagnetic spectrum. Is in terms of sentence, it doesn't make sense, because sunlight has electromagnetic spectrum in it. The part of electromagnetic spectrum can make indirect sense, that's all. But anyhow, there is a clear thing that false statement is option 3. Hope understood.
Yes, sir.
Okay. Abhinav, is that okay, man?
Yes, sir. I didn't consider charge.
That makes charge is also not there, mass is not there, but there is a field component, that's all. So a scenario of electromagnetic radiation is different from a magnet by itself and a charge by itself. Okay. So fine, with 30 and 30, totally 60 questions we have solved. We have given the materials, and there will be little more questions which we are going to take up after your test. And as I told you, quantum mechanical model, and there's little thing about Schrodinger wave equation, also things which we are going to discuss. And this Sunday, you're going to write
CET test, sir.
No,
CET test. So
sir, Saturday, no, sir.
Pardon me?
Sir, Saturday, no, sir, test.
No. Is it Saturday they have announced?
Sir, no, sir. 1st November,
No, sir,
Sunday.
Sunday, man.
Okay, sir.
What man? Go through first go through and timings and everything. And it is the first test you are going to write online by using the app. So we'll explain everything. It will be easy also, not to worry. And when you get into the app, you should not swap between the pages. Like there is a question, suddenly you cannot remove the screen and go to Google and search it. You can't do that, because it will submit. If you change the page, the entire text will be submitted. And for example, first 5 questions you have done, 6th question you will go to next page to search for something. For 5 questions only it will be submitted. So you cannot change the pages. And see, always when you write a test is always conducted to reflect what you are academically. And you should know where exactly you stand in the test, in the competition along with others. So it should be true evaluation of yourself. It should act like a mirror. So that being the case, not doing anything else, okay, searching. And since when you are alone writing the test, you should be more responsible for what you do. Okay.
Sir, in home parents will be there, no, sir. How can we even do that?
I didn't get you. What? Once again?
Sir, in home parents will be there, right? So how can we do that?
Even we would request the parents to take care of the examination and be like invigilators. Sometimes it so happens that parents may be busy. In such cases, some people tend to do that. So I would urge you people not to do all those things, because it is you who want to find out where exactly you stand in the competition. And
Yes, sir.
you need to analyze your flaws. And this is a really good app, Gnanadhara app. After writing, will give the results immediately. After that, you can analyze which question was difficult, which question you have taken more time, and which part of it
Sir?
become correct. Okay, pardon. Tell me.
Sir, once we submit our answer, we can't check it. Means at last after
No, you
submitting
can
our
check it
answers.
only when we announce the result. After announcing the
Fine, sir.
result, you will get to know your solution, your position, marks, and everything. That would happen quite immediately. Okay. So let's
Excuse
say
me,
Yes,
the
sir.
sir.
examination completes all the 3 PCM exams complete. At the end of that, within half an hour, we'll announce.
Excuse me, sir.
Huh.
So it's 60 minutes, 60 questions for each subject, no, sir?
Correct.
PCM. Okay.
Yeah, there will be gap of 1 hour for each subject. Let's say the examination starts by 8 o'clock. 8 to 9, you'll write physics. 9 to 10, there will be break. 11 to 12, you'll write chemistry. 1 hour break. Next, mathematics. After that, within half an hour, we'll publish the results. You can see the result, and then you can analyze your own paper. There will be solutions and everything in the fingertips. It is quite convenient way of conducting the test. Only thing is, students have to write quite honestly. That's all.
So what is the timings of the test?
It will be given in the WhatsApp group today or tomorrow.
Yes.
So it will be in the early hours in the Sunday, something like around 8 o'clock.
Yes, sir.
Okay, sir.
Hope this is fine. Wish you all the best for the first test. You should get very good marks. That will act like a boost for remaining exams. Okay,
Yes,
not to
sir.
worry. You will get it. So hope your first exam goes well. Thank you. We'll meet for the next class.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir.
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 Thank you. Yes, I'm going to end the meeting.